Hello everyone. Good evening and welcome to the class. So I hope that everybody is fine and in good health. Please give a confirmation that audio video is clear. Hello Story Vision. Yes everyone, please give a confirmation कि आपको आवाज आ रही है, audio video सब clear है, there is no problem. So today we'll be discussing these questions and they are from your good evening Aditi. Okay, thank you. And they are from your computer organization and digital logic, right? And today I have tried to add more questions from your gates, from your flip-flops, okay? And I'll try my best to make you understand few concepts, okay? So all those who have entered the class, quickly just send a hi or a hello so that I may know that you all are active. All those who are new here, please do join this Telegram group and subscribe to the YouTube channel as well, right? So that you can be notified about the classes and the PDFs as well. And as you all know that in the morning we have started with the machine learning course. Hello Abhiya, right? Morning may we have already started with the machine learning course and I hope that everybody is aware of it. It is on YouTube, right? And free of course. Okay, so anyone who is interested in good evening Jyoti, good evening Nisha. So anybody who is interested in learning machine learning, please feel free to join the class. Okay, so today was the second lecture of that class. PDF already मैंने Telegram पे share कर दी है, right? Just give me a second everyone, just give me a second. Okay, so audible है ना class, right? ठीक है, so please all those who are new or who will be watching this video later, join this Telegram group. And plus you all know that there are certain courses also on the website, so you can visit that website as well, right? And whichever course you feel like, you can subscribe to it, you can join it. Plus you can also install this Android app, right? So that will help you to go to app है आपके लिए बहुत ही ज़्यादा. So there are courses also available over here also, so you can visit the courses on your app as well. Okay, so all those students, those who are not coming in the morning session, I just want to say that maybe because of certain reasons, it might not be possible for you to attend live classes. But I would recommend that since machine learning is a very important subject from, not if we don't see from exam point of view, but since you all are trying to become professors, right? So it's very important that you should have knowledge of these basic topics, right? And machine learning has become a very very important topic for us being computer teachers, right? So I would recommend that since it is free of cost, it will not cost you anything. So do watch those videos, do watch those classes later in the day. If not live, then please do watch recorded as well. Okay, it will help you in the long run only. Okay, now start with the questions. So first question is, a boolean function f of two variables x and y is defined as follows. Assuming complements of x and y are not available, a minimum cost solution for realizing using only two input NOR gate and two input OR gate, each having unit cost, would have a total cost of. So what is the answer to this question? Yes, what is the answer to this question, everyone? Quickly. So in this question, what they have given us, they have given us two variables x and y, right? So we have x over here and we have y over here, and then we have given a function. So what have they given us? They have given us certain values, that is x 0 0, then we have 0 1, then we have 1 0, and then we have 1 1. So when f 0 0 will give you what? Will give you 1. Then 0 1 will give you what? 0 1 will also give you 1. Then 1 0 will give you 0, and 1 1 will give you again 1. Right? Now try doing it. You have to basically, you have, they are saying that assuming complements of x and y are not available, minimum cost solution for realizing using only two input NOR gates and two input OR gate. So you can either use two input NOR gate or you can use two input OR gate, and you have to tell that what will be the minimum cost for this function when it will be realized, and each gate is having what? Unit cost, that is cost is equal to 1 for each gate. Yes, क्विकली आंसर करो एवरीवन. बहुत इजी है ये, इसमें इतना टाइम क्यों लग रहा है? So we all know that we will take those inputs. This की value 1 है, right? So it will be what? It will be x complement y complement. Then this will be what? It will be x complement y, and this will be what? This will be x y, right? So we have to do what? Now we have to realize it. C. Okay, the correct answer is option number D, that is 2 units only. ओके ज्योति, यहाँ तक अब जब भी आई विल बी एक्सप्लेनिंग इन डिटेल, सो जहाँ भी जिस पॉइंट पे यू आर नॉट एबल टू अंडरस्टैंड प्लीज टेल मी, ओके? आई विल रिपीट दैट पॉइंट, ओके? सो व्हाट इज द वैल्यू ऑफ f now? So when I'll be applying it on the function, so f will be equal to what? F will be equal to x complement y complement plus x complement y plus xy, right? From here I have taken these values, x complement y complement x complement y and xy, and then f is equal to y. I will add these things, right? So this is very easy. Now we have to simplify it. So here I can take x bar complement or x complement common. So this will be y complement plus y plus xy. So this is equal to what? This is equal to x complement plus xy. As we all know that y bar plus y will become 1. Now we know this property, this law, that is, if I have, what it says is, it says that if you have it says that if you have a plus a complement b, if you have any type of this, it will become a plus b. Or if you have a complement plus ab, it will become what? It will become a complement plus b, right? So now here I can see that it is x complement plus xy, it will become x complement plus y. So f is equal to x complement plus y. So now I have to realize this value, this function, with the help of gates. So how can I do it? I know this thing that if I have x as an input, right? So if and what I have 2 input, right? They are saying 2 input NOR gate on 2 input OR gate, ठीक है? So और तो very clear है कि I have, now what I want x complement, and they are clearly writing that complements of x and y are not available. So what I have to do first I have to find this x complement. So we all know this, that if I apply NOR to it, right? What they are saying 2 input NOR gate. So this is OR and this is your NOR gate, right? So I can, if I apply x and x, so what will be the result of NOR? If I am having x and if I apply it with NOR x, what will be the value? What will be the result? Result will be x complement. Yes or no? So x complement ho gaya, and then I have what? Then I have y over here. So now I can simply apply OR gate to it. Why? Because they are saying that both of them are 2 inputs. So this is 2 input OR. So that will be x complement plus y. So minimum cost for this is 1, right? Each unit cost के हैं. So 1 cost यहाँ पे लग गया and 1 cost यहाँ लग गया. So minimum cost कितनी हो गई? 1 for your NOR gate plus 1 for your OR gate. So it will be 2 units. Yes or no? Clear everyone this question? Any doubt in this one? So correct answer to this question is option number D, that is 2 unit. Any doubt anyone? Clear? Next question करें. Okay. Next question is, the Boolean function y is equal to ab plus cd is to be realized using only 2 input NAND gates. Now you have what they're saying, that this is the function given to you, y equal to ab plus cd. You have to realize it using only 2 input NAND gates. So what is the minimum number of gates required for this? These type of questions are generally asked in exams, so we'll be practicing these type of questions more so that our concept is clear, that how we have to do things. I'll make sure कि आपको समझ में आ जाए कि how you have to proceed with these type of questions. But first try it yourself. They're clearly saying that you have to use only NAND gates, right? Two input NAND gates, and the function is AB plus CD. B. Okay. And what about others? चलो 1 मिनट और दे रही हूँ, जल्दी से करो, बताओ क्या आंसर आ रहा है आप लोगों का. 1 minute extra I'm giving to everyone, all those who are trying, all those who are doing quickly. So basically, what is NAND? If you talk about NAND, is first you do AND plus NOT, right? Now if we see our function, that is y is equal to AB plus CD. Now in this function there is AND, correct, but we don't have NOT over here. So how we will solve this? So what we will do is, in this type of question, is we try to add complement to our function. Okay, what we are doing is adding complement to the function. I'm not disclosing the answer right now if anybody is doing, so that they can give the answer. Okay, adding complement to the function. Now what will happen is, so it will be y equal to AB plus CD whole complement, right? But now many of you will say, ma'am, now the function has changed, right? Why it has changed? Because see, here we don't have any complement in the original function, and we have to realize this original function only with the help of NAND gates. We cannot change the originality of the question. So that is why what we will do is we will apply double complement. Okay, why double complement? With the help of double complement, what we will do is double complement will negate each other. I am writing each and every step so that whenever you will see this PDF, it will be clear to you there also. So double complement will cancel out each other. Okay, so now our originality has also been maintained, plus we have, now we will try to change our question using this NAND, not and. Okay, now what we will do is, now we will take this first complement and we will open it. So what we will get? We will get A, B complement. This plus will be converted to AND, right? Then C, D complement and whole complement. Yes or no? Right? This is what we will get. Now I can say that this has become in y. Now this function has been written in terms of your NAND, not and. क्या क्लियर करना है अदिति? क्या क्लियर करना है बताओ मुझे, फिर मैं दोबारा क्लियर रिपीट करना है वाला चीज. See, just see this thing. We have been given a function y is equal to ab plus cd. Correct. They are saying that you have to realize this function only with the help of NAND gates. ठीक है. Now NAND means that we are using and plus not. This is what is NAND. यही होता है NAND. Not plus and. मतलब आप you are doing and then you are applying not. मतलब negation. This is what is your NAND. Correct. Now in this given equation, in this given function, there is and तो है यहाँ पे, ठीक है. Between a and b we are doing and, between c and d we are doing and, but there is no complement, right? Plus यहाँ पे addition भी हो रहा है, मतलब और. तो अब now what our task is that we have to remove this or. First what we have to do, we have to remove this or, and second is we have to add what? Complement to this. ठीक है. The easiest way of doing these two things is what? Easiest way is that we can apply complement to this entire function. But when we are applying this complement, it is very visible to us that this will change the originality of the question. Why? Because अब अगर मैं इसको open या मैं करूँ तो it will become AB complement dot CD complement, right? And this and this, these two are not same. So that is why what I'll do, I will apply double complement over it, so that जो originality है question की वो वैसे ही maintained रहे. ठीक है. But अब since we have done this, so now what we will do, now we have to convert it in this form कि सारे जितने भी और हैं वो हट के एंड में कन्वर्ट हो जाए. ठीक है. अब यहाँ पे वी हैव ए एंड बी, सो वी विल नॉट टच इट. व्हाट वी विल डू, वी विल सिंपली राइट ए बी कॉम्प्लीमेंट दिस प्लस वी आर टॉकिंग अबाउट दिस वन. ओके. हम इस कॉम्प्लीमेंट की बात करें, फर्स्ट वाले की. सो नाउ वी हैव ए बी कॉम्प्लीमेंट, दिस विल बी कन्वर्टेड टू एंड, देन वी हैव सी डी कॉम्प्लीमेंट, whole complement. Now we can apply what? Now we can apply apply this with the help of logic gates. That is how what we will see कि logic gates हमने कैसे अप्लाई करने हैं. ठीक है. So now what we will do, इसका करेक्ट आंसर है ऑप्शन नंबर बी, that is 3. So all those who are getting 3, your answer is correct. Okay. So now what we have to do, now we have to apply gate to it. So if you see over here, I'll do over here. So यहाँ पे we have A, नहीं, ए बी के बीच में प्लस तब आएगा, ए बी के बीच में प्लस कब आएगा? देखो यहाँ पे हमारे पास ये आया है ए बी प्लस सी डी डबल कॉम्प्लीमेंट. ठीक है. ए बी के बीच में प्लस तब आता, व्हाट आई एम डूइंग इज आई एम लेटिंग दिस कॉम्प्लीमेंट रिमेन एज इट इज. मैं इसको टच नहीं कर रही हूँ, मैं इस कॉम्प्लीमेंट को ओपन नहीं कर रही हूँ. अगर मैं इसे ओपन कर दूं तो ये हो जाएगा ए कॉम्प्लीमेंट प्लस बी कॉम्प्लीमेंट डॉट C complement plus D complement whole complement. But what I want is I want NAND. NAND मतलब not plus and. मुझे यहाँ पे और चाहिए नहीं. I just simply want कि यहाँ पे and ही रहे. इसीलिए I'll not follow this step. I will not follow this step. I'll stop here only and then I'll try to solve it with the help of logic gate. Clear? एंड आपकी बात सही है, आप जब ए और बी के बीच में ये अप्लाई करोगे सो यू विल गेट प्लस. बट आई डू नॉट वांट टू ओपन दिस. अगर मैं ओपन करूंगी तो ऐसे ओपन होगा एंड ओपन करके व्हाट विल हैपन इज अगेन आई लैंड इनटू द सेम प्रॉब्लम फ्रॉम वेयर आई हैव स्टार्टेड. अगेन आई हैव प्लस एंड आई डू नॉट नीड प्लस. सो इसीलिए आई जस्ट नॉट ओपन दिस, आई सिंपली लेट इट रिमेन लाइक दिस. ओके. नाउ वील ट्राई टू अप्लाई गेट्स टू इट. So now when you will apply this logic gate, so you will come to notice that what has happened. So we will have A over here, correct? We will have B over here. So when I'll apply NAND to it, what will happen? What will be the result I'll get? I will get A dot B whole complement, correct? Then here I have C and then I have D. Again I'll apply what? I'll apply NAND gate to it, and what I will get? I will get C dot D whole complement, correct? Then what I will do? Again I'll apply these two as an input to the third NAND gate, and what I will get? I will get A dot B complement dot C dot D complement whole complement. So this is how I'll be doing. So this is my first gate, this is my second gate, and this is my third gate. So how many gates will be required? 3 gates will be required for realizing this Boolean function y is equal to AB plus CD. Clear हो गया? I hope now you have understood why we have not opened this complement, because it will give us plus and we do not need plus anymore with our function. We simply have to solve without the use of plus. Clear everyone? Okay, next question. Again, next question is also of the same type. Minimum number of 2 input NAND gates required to implement the function. What is the function? Function is, I'll write again very clearly, x complement plus y complement, and then we have z plus w. So you have to use again NAND gates, and then you have to tell how many minimum number of NAND gates will be required for solving this question. So basically, when you have these type of questions, you should know what you have to know, that how you have to apply, how you have to basically solve these, simplify these functions so that you can convert it in the form of NAND. That is not plus AND. Okay, correct. So correct answer is option number B, that is 4. 4 gates will be required. Now how you will be doing this question? See, now in this what we can do is we can simplify it according to our preference. Okay, डबल वाली चीज तो बाद में we'll see. First what we can do is we have two plus over here. ठीक है, so what we will do is we have this plus and we have this complement. So just tell me this x complement plus y complement, can I write it as like this, x dot y whole complement? Can I write this x complement plus y complement as x dot y whole complement? So when I'll open this, what I'll get x complement plus y complement. Yes or no? Good evening, Neetu. Good evening. Okay, right. So now what I will do is, now I'll try to simplify this. How will I do? What I will write over here is, I will write it as x y whole complement multiply by z plus w. So my function f will become what? F will become x dot y whole complement dot z plus x dot y whole complement dot w. Yes or no? Okay, now what I'll do, now I'll start by taking the double complement. So now I'll apply double complement. So it will become what? F will be equal to x y complement dot z plus x y complement dot w whole complement. Double complement we are doing, so whole double complement, correct? Now what I'll do, now we will be using this complement first, so it will become x y complement dot z whole complement dot, this will become dot x y complement dot w whole complement, and then we have this complement, this is your double complement, correct? ये समझ में आ गया इतना? So now for this I have to make my diagram. For this function I have to make my logic gates. ये समझ में आ गया everyone? Correct. Now I'll be drawing the logic gate for this. So what we will do is, first we have x, then we have y, right? So we have again NAND only, so we will get what? We will get x y whole complement, correct? Then what I will do, first I'll apply it with z. I'll take this, I'll take one NAND gate again and I'll apply z to it. So what I will get, the result that I will get is x y complement dot z whole complement, and again I'll take this and apply w to it. So what I'll get, x y whole complement dot w whole complement, correct? Then what I will do, now I will take this, then I'll take this one, again I'll apply it with double complement. So what I'll get, let's say I'll get f. So what I will get, x y complement dot z whole complement and x y complement dot w whole complement and whole complement. So how many gates do I require? 1, 2, 3 and 4. So how many gates? 4 NAND gates will be required, correct? Okay, next question. Next question. An unpipelined machine with 10 nanoseconds clock cycles. Okay, so we have a non-pipeline machine. It is having how many clock cycles? 10 nanoseconds it is for clock cycle. Its ALU operation use 4 cycles and branches, whereas 5 cycles for memory operations. Assume that the relative frequencies of these operations are 40%, 20%, 40% respectively. Let, due to clock skew and setup pipelining, the machine adds 1 nanosecond of overhead to the clock. The speed in the instruction execution rate will gain from a pipeline will be dash times. I won't explain anything in this question. Just try it yourself and उसके बाद फिर I'll explain कि क्या करना है इसमें. दिस इज वेरी इजी, वेरी बेसिक क्वेश्चन है, बट सिंपल सी थोड़ी लैंग्वेज हो सकती है कि आपको थोड़ी सी कंफ्यूजिंग लगे. रेस्ट ऑल इज वेरी इजी एंड वेरी अंडरस्टैंडेबल. ओके. See, in this question, what they have done is, what basically they are doing is, they have taken a non pipeline system. ठीक है, non pipeline machine है जिसमें जो clock cycle is taking 10 nanoseconds. Okay, then in that non pipeline there are ALU operations. ठीक है, then ALU operation is using 4 cycle, and branch operation is also using 4 cycles. Then memory operations are taking 5 cycles. ठीक है, then they are saying that frequencies of these operations are 40%. So ALU की frequency है 40%, ब्रांच की फ्रीक्वेंसी है 20% एंड मेमोरी की फ्रीक्वेंसी है 40%. ओके, सो व्हाट दे आर सेइंग दैट यू हैव अ नॉन पाइपलाइन. बेसिकली इट हैज फॉर फ्यू ऑपरेशंस, out of which few are of ALU, then they have branch operation, and then they have memory operations, and their frequencies are given to us. Then they are saying that on this non-pipeline machine, what they have done, they have converted this non-pipeline machine to pipeline one, and now the pipeline machine adds 1 nanosecond of overhead to the clock. ठीक है, so they're asking that what will be the speed in the instruction execution rate. So basically they're asking that what will be the speed up, what will be the speed up when you will convert from your machine from non pipeline to pipeline. So that you have to tell. अब हो जाएगा, ट्राई करो. So how we will do this question is, first what we will do, first we will deal with the non-pipeline. Okay, so let's take the non-pipeline case. So what is the instruction execution time? If I have to talk about average instruction execution time in case of non-pipeline, anyone? It is equal to the clock cycle that we have when we don't have number of stages. ठीक है, अगर number of stages नहीं दिए, in that case how we'll find the instruction execution time? Clock cycle multiplied by average CPI, clock performance. Okay, so now what will be your average CPI? Now first we have to, what is clock cycle? Clock cycle is 10 nanoseconds, but we don't know what is the value of average CPI. So what will be average CPI? So 40%, we have 4 cycles for ALU. So 4, that is 40% plus, what I will do is, your ALU and branch all are taking, both are taking what? 4 cycles. So 40 plus 20 multiply by 4 plus 40 multiply by 5. So this is for ALU, this is for branch, and this is for memory. So when you will solve this, you will get what? You will get 4.4 nanoseconds. So average instruction execution time will be 10 nanoseconds multiplied by 4.4 nanoseconds, that is 44 nanoseconds in case of non-pipeline. So non-pipeline के केस में the average instruction execution time is 44 nanoseconds. Okay, then what is the average now for, let's talk about pipeline वाला case. Okay, so pipeline वाले case में average instruction execution time is what? It is equal to clock cycle plus overhead. We don't take these things separately. Why? Because pipeline के केस में क्या होता है? Pipeline में all these things work hand in hand, right? So pipeline के केस में all these things go hand in hand, so we don't take this thing. So then what we have? What is clock cycle? Clock cycle is your 10 nanoseconds plus overhead is of 1 nanosecond, so it will be 11 nanoseconds for pipeline. So therefore, what will be the speed up? Speed up will be non-pipeline divided by pipeline, that is 44 divided by 11, that is 4. So speed up turns out to be 4. This means that the answer will be 4 times. So speed up is what? That is instruction execution rate that will be gained from pipeline will be 4 times. I hope this is clear to everyone now. Okay. Next question. There is one more question. There's one question that is a microcontrol unit is having control word in the following format. Okay, the format is condition, control field information, and next address. They are saying it has to generate 46 control signals and next address are selected based on 8 conditional या फिर flag information. If the control memory is having 80 control program of size 8 words, the size of control word in horizontal microprogramming is how many bits? So basically they're asking you that if you are using horizontal microprogramming, then in that case, what will be the size of the control word? What will be the size of the control word? How many bits will be there? what they have given to us is they have given us control signals, right? So control signals kitne hain? 46 control signals. Okay, so how we will do this type of question is that when we are dealing with horizontal programming or horizontal microprogramming, so what happen is that we have what we have to find, we have to find the size of control word. Okay, and control word is having what? It is having some block for condition, some bits for control field information, and some field for next address. Okay, so control field information in this case, it is 46 control signals, right? So how many bits will be reserved for this one? In horizontal microprogramming, it has more number of control signals. Okay, so control signals ke liye we have how many bits? We have 1 bit for each. Okay, this means that how many bits we have for control signals? 46 bits are given for control signals. ठीक है, so इसके लिए हो गए आपके पास 46 bits. Now we have condition flag, right? So we have what? We have 8 conditional flag information. So 8 के लिए कितना हो गया? 8 will be given how many bits? 2 raised to power 3. That is 3 bits will be given to this condition. Correct. Then we have control memory. So control memory में what they are saying, if we talk about your control program, ठीक है, that is for next address, what we are saying is address कितने bits का होगा? How you will find this? 80 control program of size 8. So 80 multiply by 8, that is 640. And 640 के लिए how many bits do I require? 2 raised to power 10. That is 10 bits I require for control program for next address. So 10 bits. So how many total bits? 3 plus 46 plus 10. That will give you what? That will give you, sorry, that will give you 59. So how many bits are there for horizontal microprogramming? 59 bits का आपका control word होना चाहिए. Clear? Okay. Now tell me, if instead of horizontal microprogram, if they would have asked for vertical microprogramming, then what would have been the answer? सब कुछ same रहता, but the only change they would have done is that what will be the size of control word in vertical microprogramming? Then what would have been the answer? Vertical microprogramming. Yes, there is डिफरेंस. या मैं जो नेक्स्ट क्लास होगी उसमें मैं ऐड कर दूंगी डिफरेंस हॉरिजॉन्टल और वर्टिकल का. ठीक है, तो आपको क्लियर समझ में आ जाएगा कि व्हाट इज द डिफरेंस बिटवीन द टू. बट फिलहाल के लिए अभी व्हेन आई एक्सप्लेन वर्टिकल तो उसमें आपको समझ में आ जाएगा कि क्या डिफरेंस है. तो व्हाट इज द डिफरेंस फ्रॉम वर्टिकल माइक्रो प्रोग्रामिंग? अगर हम वर्टिकल माइक्रो प्रोग्रामिंग का कंसेप्ट अप्लाई करें, देन व्हाट विल बी द साइज ऑफ कंट्रोल वर्ड? See, in vertical programming has basically less number of control signals. Okay, so number of bits for control signals will be what? Now in horizontal programming, number of bits for control signal was 1 bit for each control signal. ठीक है, 1 bit for each control signal. But here what will happen is we have 46 control signals. So number of bits will be what? Number of bits will be 2 raised to power 6. ठीक है, that is 6 bits will be required for control signal. This is the difference between vertical programming and horizontal programming. Conditional के लिए everything will remain same. Conditional के लिए we have 8 flags, so it will be 2 raised to power 3, that is 3 bits. And control program के लिए everything will remain same, so that will be how many bits? That will be 10 bits. Rest all will remain same. The only difference is in terms of control signals. Okay, so vertical programming में horizontal programming के case में we were having 1 bit for 1 signal, but in vertical programming we have less control signals, so we will have log, we will do log of it. So control size क्या हो गया, control word control आपका जो word है उसका size 6 plus 3 plus 10, that is only 19 bits. So in case of vertical programming we are using only 19 bits, but in case of horizontal programming we have to use 59 bits. So that is the difference between, basic difference between horizontal microprogramming and vertical microprogramming. So kabhi question aayega, so aise you have to do it. Okay. Yes Jyoti, that is what I'm saying कि I'll share the difference with you. कल की क्लास में, हम कल की क्लास में करेंगे, तो उसमें आपको मैं हॉरिजॉन्टल और वर्टिकल का जो बेसिक डिफरेंस है, जो कंसेप्ट है, वो एक्सप्लेन कर दूंगी, ठीक है. तो उससे आपको और क्लियर हो जाएगा विद द डायग्राम एंड ऑल, आपको ज़्यादा क्लियर हो जाएगा कि क्या डिफरेंस है बिटवीन हॉरिजॉन्टल माइक्रो प्रोग्रामिंग एंड वर्टिकल माइक्रो प्रोग्रामिंग. ओके, सो आज के लिए आई कीप इट टिल हियर ओनली, ठीक है. एज देर आर स्टूडेंट्स भी ज़्यादा नहीं है आज की क्लास में, लेट्स सी कि कल की क्लास में कितने रहते हैं, ठीक है. सो बिकॉज देन वर्टिकल प्रोग्रामिंग इज मच एफिशिएंट, आप कह सकते हो बिकॉज इट इज यूजिंग लेस नंबर ऑफ बिट्स, बट ऐसा जरूरी नहीं है. इन सम केसेस इट कैन बी कि हॉरिजॉन्टल माइक्रो प्रोग्रामिंग इफेक्टिव हो जाए. आई एक्सप्लेन टू इट, ठीक है, आई एक्सप्लेन दैट टू यू. ओके, सो पीडीएफ जो है आपको, पीडीएफ विल बी प्रोवाइडेड टू यू आफ्टर कवरिंग फ्यू क्वेश्चंस, ठीक है. आज नहीं, होमवर्क. चलो ठीक है, एक क्वेश्चन दे रही हूँ मैं आपको. एक क्वेश्चन है जो आप ट्राई करके आओगे, इसका स्क्रीनशॉट ले लो आप लोग, ठीक है. ये क्वेश्चन है, टेक द स्क्रीनशॉट ऑफ दिस क्वेश्चन एवरीवन. कल जब क्लास स्टार्ट होगी तो वील बी स्टार्टिंग विद दिस क्वेश्चन ओनली, एंड दिस इज द होमवर्क. इसको ट्राई करके आना है. यस, दिस सीरीज विल बी इन कंटिन्यूएशन. एवरी इवनिंग वील हैव क्लास, समटाइम्स एट 4 PM. उसके अकॉर्डिंगली, या फिर टाइम जो है वो आपको टेलीग्राम पे मेंशन कर दूंगी मैं, कितने बजे क्लास होगी, बट रेगुलर क्लासेस होंगी. ओके, सो यस, स्क्रीनशॉट ले लिया सबने इसका. ये क्वेश्चन है और ये आपको ट्राई करके आना है. ओके, हाँ, आंसर आपने कमेंट सेक्शन में दे सकते हो, कमेंट सेक्शन में दे दो, नहीं तो वील डिस्कस टुमारो इन क्लास. ओके, या यू कैन पुट योर आंसर्स इन कमेंट सेक्शन. ओके, ठीक है, चलो, तो सी यू ऑल टुमारो, ठीक है. टुमारो क्लासेस विल बी अराउंड 4 PM पे क्लास होगी. आज कुछ वजह से आई हैव टू डिले द क्लास, ठीक है. सो प्लीज बी ऑन टाइम. ओके, एंड वॉच दैट मशीन लर्निंग वाली वीडियोज एज वेल, ठीक है. लिंक आपके ग्रुप में शेयर कर दिया है, सो वहाँ पे आपको और अच्छे से समझ में आ जाएगी चीज़ें, ठीक है. सो मशीन लर्निंग एक अच्छा कंसेप्ट है, और फ्री में अगर वो चीज़ आपको अच्छे से समझ में आ रही है, सो आई डोंट थिंक देयर इज एनी प्रॉब्लम विद दैट. सो प्लीज एवरीवन डू विजिट दोज क्लासेस एज वेल. ओके, चलो, थैंक यू एवरीवन, बाय बाय, टेक केयर.